So in this question, we're told to determine the delta S, the change in entropy, for the phase change of 1.1 moles of water from solid to liquid at 0 degrees Celsius. And we're given the delta H of fusion for water, which is 6.01 kilojoules per mole. A couple things. First of all, we're going to need this to be in Kelvin, so we know that we convert degrees Celsius to Kelvin by adding 273. So the temperature is going to be 273 Kelvin. Anytime you're working with entropy, you need your temperature in Kelvin. And also keep in mind that what we're doing here is we're melting solid into a liquid, so this means that it's going to be a positive value. And you're going to have an endothermic process. All right, so one thing we need to remember is that an entropy change is related to the amount of heat that's transferred divided by the temperature, or it's calculated as the amount of heat that's transferred divided by the temperature. Well, we can remember from Chem 1 that for a phase change, the way in which I can calculate Q is that it's equal to that delta H of fusion times the number of moles, times N. So that's going to be equal to 6.01 kilojoules per mole times 1.1 moles. Okay, so moles cancel, and I'll get kilojoules. And that comes out to be 6.611 kilojoules. Okay. So I'm just going to use that right here in this equation, and I'm going to use this temperature as the temperature to calculate the delta S. So it's going to be 6.611 kilojoules divided by 273 Kelvin. And if you do that calculation, you get 0.0242 kilojoules per Kelvin. But we typically will express entropy values as in units of joules per Kelvin. So I can multiply this times 1,000 and move the decimal place over 3. And so it becomes 24.2 joules per Kelvin. Okay, so that would be the answer. And it makes sense because what you're doing is you're going from a solid to a liquid. And we know that liquids have more entropy than solids. So it makes sense that this change in entropy is a positive value. It's a positive change in entropy.